and we like the name Alpha because it can mean best or leader. And also Google's parent company is called Alphabet, so it's a reference to that as well.
We actually use two neural networks to guide that simulation. So it uses a policy network to actually only consider the most effective moves that are given by the neural network trained from human play. So in other words, you can think of this as there being almost like a human standing over the searcher's shoulder, suggesting which move to play at each step of the simulation. And secondly, which is a big difference from previous approaches, we actually have something which is the value network, which is able to evaluate a position in the game of Baduk. We supply, so we had a human operator during the match, and the human operator played the games physically on the board and also entered them into the computer using a standard interface. So actually, the program AlphaGo itself is already told in machine-readable format what the board position is for each move and what move was actually selected by the opponent. And so this information is provided directly, so it doesn't have to extract this for itself by interacting with its environment directly.
The data, it could have generated the data itself. It still requires playing many millions of games. So it still needs a lot more practice, let's say, than a human expert player would. So humans are still more efficient at learning, and that's something that we are working on as well in a separate project, is to try and learn from fewer examples. So in neuroscience, this would be called one-shot learning, where humans are able to learn even from just one example by using knowledge they have from other domains. So this is something computers still aren't able to do, but it's also something we're working on.
AlphaGo was trained for around 4 weeks of non-stop time of actually observing human positions, one after the other after the other. I believe top human professionals play something like 1,000 games a year for the new generation who play a lot online, which would mean, I guess, that AlphaGo is processing something like 1,000 years worth of. Does AlphaGo make mistakes? So AlphaGo, as we said, is based upon a Monte Carlo tree search, which means that it uses randomness at its heart. And this means that there is always a small probability that it can make a mistake at any given moment. And what we try to do is, by searching deeper and thinking for longer, and also by training our neural networks over more games and more positions for more time, we manage to reduce that probability of a mistake to a lower and lower threshold.
Games are the perfect platform for developing and testing AI algorithms. It allows us to test out our algorithms very quickly and efficiently. But ultimately, we want to apply these techniques to important real-world problems, not just games. But because the methods we've used are general purpose, our hope is that one day they could be extended to help us address some of society's toughest and most pressing problems, including things like medical diagnostics, climate modeling, and smartphone assistance. So we're very excited to see what we can use this general technology to tackle next. Basically, to try and solve a game, try and beat a game like Paddock, you have to have quite a few different features and capabilities of your program. So you have to be able to use pattern recognition to understand the board. And then we use reinforcement learning for the system to improve through experience. So we think actually the type of algorithms we're building, they're not specific to playing Go or Paddock. They are general algorithms that can learn from any kind of data. So these are quite generalizable algorithms.
So we haven't special cased our program to play any particular player. Of course, Mr. Lee is an exceptional Go player, and we fully expect the challenge to be enormous. But right now, we are just focusing on making the strongest possible player in general terms, and we Indeed, it's actually rather hard to special case to a small number of games from any individual because our machine learning techniques are very general and take as their input millions of human positions.
If we lose, then yes, we would probably like to have a rematch. But again, the details of that are still to be decided. And again, we're just focusing on this first match and hopefully trying to win that. If we win, then I think we would have to consider again like what the next step would be. I think we would have to see how the games went, and then maybe see if the International Go Federation and the other Go federations would accept a program maybe playing in a bigger tournament. So, but again, we haven't planned for anything on that front yet. Again, we're just concentrating on the match with Mr. Lee.